My name is Osama Rawashdi. I'm the chair of the Electrical and Computer Engineering Department. We would have loved to have you in person, but I guess it wasn't meant to be this year. Hopefully, we'll have you next year in person on campus. I'm here with two colleagues, Professor Brian Dean and Professor Hongwei Q, who will have his camera on as well. So we prepared a few slides for you just to kind of generate some questions and kind of introduce you to the department. So I'll pass it to Professor Brian Dean first.
Hello, I'm Professor Brian Dean. I'm the Academic Programs Coordinator, helping with all kinds of issues that may come up as you're going through the program and issues with, prerequisites or things like that. We have a very great advising team that does much more work with the undergraduates than I do, but that's kind of my role at this university as far as in the department. And then I also teach some classes within the electrical and computer engineering department. So I would like to start by just going over some of the programs we have here at Oakland, and within our department, we have the Bachelor's of Science and Engineering in Electrical Engineering, focusing in areas of things like controls, signal processing, go into power, and then we have our Bachelor of Science in Engineering, in Computer Engineering, and in Computer Engineering, we have an embedded systems kind of focus, looking at all the microcontrollers and FPGAs and things of that nature that go into all of our smart devices. And we were one of the first universities to have a MS, a master's degree in embedded systems. Both of the programs at the undergrad level are ABET accredited. We just recently went through our ABET accreditation cycle and received another 6 years worth of accreditation, which is the max you can get. There's double majoring possible between these two majors. You can double major in electrical and computer engineering, and all that it requires is a minimum 12 additional credits. And so it turns out to be about 3 to 4 classes, depending on how you plan your schedule. We have great internship placement rates above 90%, and the placement into either an engineering career or into grad school for our graduates is also well above 90%. And so we are a research institution, and so all of the faculty you'll be being taught by here all have PhDs. They're all working in research, and we have 3 master's programs. So if you wish to stick around at Oakland University and continue into deeper studies, there's one in electrical and computer engineering, one that kind of mixes mechanical and electrical engineering together with mechatronics, and then one that's focused on computer engineering and embedded systems. And then we have a PhD program that's run by our department, the Electrical and Computer Engineering program, and a PhD program in Systems Engineering. So if you would like, you can stick around for, like I did at the University of Wyoming, for 10 years and get all of your degrees from one place. But we have that available to you.
Enrollment has been growing pretty significantly over the last 2 years. So here you can see the enrollment just in our department, the Electrical and Computer Engineering. So when I joined in 2007, we're like less than 300 students. And it's been amazing, this growth. So I'm sure that speaks, at least in my opinion, I may be a little bit biased, but to the quality of our program, to the kind of preparation we do for our students and the placement we get in the industry and so on. So it's a pretty exciting time. If you're wondering about COVID, you see a little dip here last year. I don't have this year's data yet. From last year, it's about 2.5% or so dip only, which is okay compared to other schools, especially to other universities. So it's definitely, the field is exciting, our programs are exciting, and the job field is exciting as well. This came out last year. Grad Reports produced a list of 25 best colleges for electrical engineering. And this is not some survey, survey that was sent to a few people. This is all based on the Department of Labor and Department of Education statistics. And in it, we are in pretty good company. We have Ann Arbor at number 9, OU number 10 in the country for EE grads in terms of median salary after graduation. UCLA is next, Stevens, Michigan State, and so on. So pretty good company here. Professor Dean and I were talking about how do we describe to you what is electrical engineering and what is computer engineering. At being in high school, you probably still have a lot of questions about that, even what major to pick. So we started making our Venn diagrams and coming up with some lists, but we thought, let's put up some pictures. I think at this stage, just showing you about some of the exciting things happening in forms of pictures and describing them may work a little bit better. We have a National Science Foundation funded professor that works in social robotics in the top left, you can see here. We have an autism center on campus, and they're developing robots and AI algorithms, smart rooms to help with autism-related challenges. We have several state-of-the-art microscopes. Professor Hongwei Q is actually the master of these microscopes, so I hope I don't make any mistakes. We have several of them used for developing of electronics, MEMS devices, tribology type work, studying materials and relation with friction and so on. We have a vehicle-size antenna range. Manufacturers bring their brand new model cars out to our campus. We spin them around. We move this arm and collect RF radio frequency signals to analyze and evaluate how well their antennas work. And you know, communication is becoming a really critical thing with cars, with more autonomy and more interconnectivity and so on. We have a international ground vehicle competition and a lot of work being done in the area of autonomous robots and autonomous vehicles. I specifically picked this picture because you may recognize those white tents, and you've seen them in the past over the last 25 years or so on the corner of Adams and Walton. This is our international ground vehicle competition. It happens every year, except for last due to COVID, where tens of teams from all over the world come and compete building these ground robots. And we have a student organization being really successful in competing. We have a lot of research going on in image and signal processing, really big focus now from the industry on autonomous vehicles and a car's ability to detect obstacles, right? So we need cameras, we need computers and GPUs to do a lot of processing to detect pedestrians walking or obstacles and so on for these autonomous vehicles. A lot of interest in drones. We have a drone certificate program for getting you certified to fly drones. We developed the first flying diving drone, and you can see some pictures here of it. We are in the process of creating a virtual reality center. A lot of companies already committed to creating this. It's going to happen within a few months, the initial opening. It was started with Epic Games with a budget about $2 million for the first 2 years. And the idea here is to use VR technology to support industry, to apply VR technology to help in industry and maintenance. And in terms of electronics, I picked this project here. We're talking about LEDs obviously being the new source of light nowadays. There's a lot of control and characterization and circuitry that they have to build to efficiently use those for lighting purposes. Okay, so this kind of hopefully gives you an idea of what electrical and computer engineering is. A lot of overlap, a lot of processing, but a lot of controls, electronics, image processing, communication, antennas, electronics, right? And all of this would fit into ECE. We have a lot of research going on that involves undergraduate students. We have a lot of student organizations also that allow you to get involved in these things. Thank you very much. Hopefully this has given you a little bit of an overview of who we are and generated some questions.